Okay, this is a retake on problem number 7. We're looking for where the function is equal to 0 in that first period. So we factor out the cosine x, set it equal to 0. That will be 0 whenever cosine is 0, or whenever cosine of x plus 2 is equal to 0. Whenever cosine of x is 0, cosine of x plus 2 is 0. And the first one will equal 0 at pi over 2 and 3 pi over 2. Now the second one, cosine of x plus 2, will be 0 whenever cosine of x is equal to negative 2, and that never happens. So those are the only two values at which the original function has a 0 on the first period. Second question, find all values of x in that period at which the function has a minimum. And we state that f of x will have a minimum when f prime of x changes from negative to positive. And so we need to find the first derivative then. We want the derivative of cosine square of x, which is a chain. We're going to use the chain rule for this. Bring that to 2. 2 times cosine of x to the first power now times the derivative of cosine of x, which is negative sine x. And simplifying gives me negative 2 cosine x sine x for the first term, and then negative 2 sine x for the second term. Again, if we want to find the zeros, the easiest way is to factor, and we're going to factor out a negative 2 sine of x, and that leaves negative 2 sine x times the quantity cosine of x plus 1. That will be 0 whenever sine x is 0, and whenever cosine of x is equal to negative 1. And that will happen when x is 0 or x is pi. So we make a sign chart from that. Select some test values in those intervals. Let's try pi over 2 and 3 pi over 2. And we plug in and let's see what we get. Negative 2 times sine of pi over 2. Sine of pi over 2 is 1 times negative 2 is negative. Cosine of pi over 2 is 0 plus 1 is positive. Negative times positive is negative. And then cosine of 3 pi over 2 is going to be 0 as well. Sine of 3 pi over 2 is negative 1. So we're going to get negative 2 times negative 1, which is positive 2, and then times positive 1 gives me positive. And so we see the function decreases, then increases, giving us a minimum at x equals pi. And so we complete our justification above there. Alright, now we're going to go into part C. We want to find out when the curve is concave up. And it's going to be concave up when second derivative of f is greater than 0. So we need to find the second derivative, and I'm going to use an identity at this point to rewrite the first derivative before I find its derivative. And that identity is 2 sine x cosine x equals sine of 2x. So I'll rewrite that part of the first derivative, and I get, for my first derivative, it's negative sine of 2x minus 2 sine of x. And I'll find the second derivative from that. Okay, the derivative of negative sine of 2x is going to be negative cosine 2x times 2, and then minus 2 cosine of x. And I want to solve for where that's 0, and I'm going to, that's difficult to do in this state. That may be possible. Some of you may have a way to do that. But what I'm going to do is use another identity, and that is that cosine of 2x is equal cosine square of x minus sine square of x. And if I factor out a negative 2, and that should give me cosine square of x minus sine square of x in parentheses, and then it's plus cosine x since I factored out a negative 2. You have to watch out for that sign again. Now I'm going to use one more trig identity and rewrite with that, replacing sine square of x with 1 minus cosine of x, square of x. But just being careful for the negative sign there. Now with a final simplification, I get negative 2 times 2 cosine square of x plus cosine of x minus 1. And this gives me a quadratic form that can be factored, and then we can find out where the zeros are. And the final factored form is negative 2 times 2 cosine x minus 1 times cosine x plus 1. And we'll solve for that equals 0 in the next video.